continuous. Now, whenever we have the function sine inverse or you have cosine inverse, we know that sine inverse and cosine inverse are going to be continuous whenever the inner function here is between -1 and 1. So looking at 25, I see that the inner function here is x plus 2. So I will say x plus 2 should be between -1 and 1. Now I need to solve for x. So in order to solve for x, I can subtract -2 from all sides. Plus 2 minus 2 will get cancelled. So now x is between -1 minus 2 is -3. 1 minus 1 is -1. So now I will say that the interval is from -3 to -1. And that's it. Okay. Now for question number 26. We need to remember something about the line function. Whenever you draw the line function looks like this. Now, the line function can only accept positive values of x. It cannot take negative values. So whenever I say line of whatever, this thing here should be positive and more than 0. Why? Because at 0, the function keeps going down to negative infinity. So the 0 is a vertical asymptote for the line. Okay. Coming to question number 26. In order to know whether this is continuous, I need the inside of the line, which is sine x in this case, to be more than 0. Notice that I didn't put equal. Okay. Now, when is sine x more than 0? Well, again, you need to remember something about the sign. The sign starts from 0, goes up, down, back to 0. Now here, the first 0 happens at pi, the second 0 happens at 2 pi. Okay, now I need the sign to be positive, more than 0. So where do I see that the sign is positive? Here. From here to here. Positive means above the x-axis. Where is this happening? Between what and what? Between 0 and pi. So I will say the sign is positive between 0 and pi. Now, is this the only interval? Well, no. Why? Because the sign keeps on oscillating. So it is not only positive between 0 and pi. It can also have another interval where it is also positive. So how will I know the general answer for all the intervals? All you need to do is add 2k pi to both sides. Now, what does this 2k pi mean? 2 pi is the period of the sign. So the sign repeats itself each 2 pi. K is a constant representing which repetition are we talking about? So when k is 0, we are talking about the first interval. When k is 1, the next one, and so on. So my answer is going to end up being 0 plus 2k pi is 2k pi. And here I have pi plus 2k pi. Now, looking at the second interval, I see pi is repeated. So what some solutions do, they take the pi as a common outside. And what will be left? 1 plus 2k. And that's it. This is the interval where the sign will always be positive. Now, what if in the final they ask me where is this not continuous? So this can happen also. I know that the sign is going to be not continuous. The line sign will not be continuous whenever we are in the negative part of the sign, because the line cannot take anything that will make this minus. So where is this happening? You see it is happening between pi and 2 pi. Again, what do you do to each one? You will say plus 2k pi plus 2k pi. So now the answer is going to end up being pi into 1 plus 2k, and the other one is going to be 2 pi, if I take 2 pi as a common, 1 plus 2k. So this is if the question says where is the function not continuous. Now we go to 27. 27 has a numerator and it has a denominator. Whenever I have a function that has a numerator and a denominator, I need to know the following. A function can never have the denominator to be equal to 0. So whenever the denominator is 0, the function will not be continuous over there. So this is where I start here. I see that this function has a denominator. So I will say x squared minus 2 equal to 0 when? Well, if you solve this, you will get x equal to root 2, x equal negative root 2. So now I know that these values will make the denominator 0, which is not allowed. So I will say x cannot be equal to this, x cannot be equal to this. Okay, what else? Now we go up to the numerator. I see I have e power x. E power x is a function that is always continuous. So this one will not make any problems for us. Now I go here. I see root, square root, x plus 1. Is this continuous everywhere? Well, no. This is a square root. So I know that the square root of x plus 1 will be continuous when the inside is greater than or equal to 0. So this means x is greater than or equal to minus 1. Now I need to know what interval satisfies these two conditions. I will draw a small line. I will put the numbers. So here I have minus root 2 as a decimal is minus 1.4. So here is minus root 2, here is minus 1, here is root 2. Now I know from here that we cannot have root 2 and minus root 2. So I will put an x, I will put an x. These values are not allowed. From here I know that x should be more than or equal to minus 1. So anything more than minus 1. So now, where do I see that both happen? I see they are happening both here. Except this should be excluded. So how can I write my answer? I can say that from minus 1 to positive infinity, this is allowed. Except, so I will say where, comma, where x cannot be equal to root 2. So this is one way to write my answer. Another way to write my answer, I can say from minus 1 till root 2. Notice I put root 2 with parentheses, not bracket, because root 2 should not be included. And then from root 2 to positive infinity. The last one in question number 5 is this one. Now I see that in this one we have a numerator and we have a denominator. Okay, so whenever I have a numerator and a denominator, I know that number 1, the denominator cannot be equal to 0. But here I also notice that the denominator is a square root. So what do I know about square roots? Square roots are continuous whenever this thing inside is more than or equal to 0. But now, since this is in the denominator, we are going to exclude the equal to 0. So now, number 1, I can see that square root of x squared minus 2x is going to be continuous whenever this inside is more than 0. Again, why didn't I say more than or equal to 0? Because now here it is in the denominator. So I start solving. X squared minus 2x equal to 0. So this means what? X is equal to 0. X is equal to 2. Again, you can factor this using mod 5-3. You will get 0 and 2. So this means I will draw a line. I will put 0. I will put 2. And now I will start taking test points before and after. So before 0 I can take minus 1. Between 0 and 2 I can take 1. After 2 I can take 3. Now we start substituting here to check where this is positive or negative. If I were to substitute 1, I will have 1 squared minus 2, which is going to give me what? Negative. If I were to substitute 3, 3 squared minus 2 times 3, that will give me positive. If I were to substitute minus 1, that will give me also positive. So this means that this is continuous anywhere greater than 2 and anywhere less than 0. Not including the 0 and the 2, because now this is in the denominator. Okay, so now we are done with the one that is down. We go to the one that is up. Ln x squared minus 1. Again, what do we know about the ln? We know that the ln is going to be continuous whenever what is inside is more than 0. So I will take the inside and I will solve it to 0. I will get 1 and minus 1. Again, I will draw a test line. I will put minus 1. I will put 1. And I will take test points. So between minus 1 and 1, I can take 0. Here I can take 2. Here minus 2. If I substitute 0 here, I will get negative. If I substitute 2, positive, negative 2, positive. So this means this is continuous anywhere more than 2 and anywhere less than, not 2, we look at the number here. Anywhere more than 1 and anywhere less than minus 1. Not including the 1 and the minus 1. Why? Because they will make the inside of the ln 0, which is not allowed. Now what I need to do is I need to combine these two intervals together so that I can see where is the common between them. So if I were to write the answers of this on this interval, let's see what we will get. So here we agreed that we need anything more than 1. Where is 1? Here is 1. So this is 1. I need anything more than 1. Minus 1 is somewhere over here. I need anything less than minus 1. So now, where is the common between both of them? Well, here, both of them, they say what? This one says less than 0, right? This one says less than minus 1. So both of them are in common where? When it is less than minus 1. So we go from minus infinity till minus 1. Not including the minus 1. So I put what? Parenthesis. And now where is the other one? Now look. This one says more than 1. This one says more than 2, but not including 2. So where do I see the common? I have to start where? From 2. So I say from 2 to positive infinity. Again, not including the 2. Why? Because it will make the denominator 0. And this is the final answer for this one.